Yeah, welcome to this channel. You are welcome. Good morning, good afternoon, good evening, wherever you find yourself across the globe. We are still continuing the use of variations of parameters. Okay, the use of variations of parameters to solve non-homogeneous second order differential equation. Okay, get the homogeneous equation. Get the homogeneous equation. That's step one. And that will be equal to what? This second differential, where the this will be equal to the homogeneous equation will be the differential equation equal to 0. That's your step one. Okay. Step two, get the auxiliary equation. And the auxiliary equation is of this standard form, where A is the attachment to your second differential, but this one is R squared. Okay, attachment to your second differential here is 1, so that will be 1 times R squared. We have that here. This is R, and I said R indicates first differential. There's no first differential here. Okay, so we cannot correspond anything in this place. Okay, the attachment to your Y is the C. This is a constant coefficient. Attachment to your Y is the C, so that's 4 equal to what? Equal to 0. So R squared is going to be equal to what? Minus 4. So R is equal to what? Plus or minus square root of what? Minus 4, which is equal to what? Square root of 4 times the square root of minus 1, which is what? This will give you 2. This will give you I. Okay, and that will be what? Plus or minus. That will be plus or minus 2I. Okay, which we can write in this form. The real part, because when you have a complex number, you must have the real part and you must have the imaginary part. The real part is what we call the alpha. The imaginary part is the I function. The attachment to that I is what we call the beta. Attachment to I is what we call the beta. Okay, sorry, this one is 2I. This is 2I. So beta is 2. Attachment to your I is the beta. So beta is 2. Our beta is 2 in that case. So once you have two distinct complex roots and your real part is 0, the solution will be what? Y1 will be equal to what? Cos what? Cos 2x. Because the e function, the exponential function to power 0 is 1. Okay, then the y2 will be equal to what? Sine 2x. Okay, this is what I'm using for y1. This is a formula: alpha x cos beta x. For y2, alpha e to power alpha x sine what? Sine beta x. So that's what we use. So we've gotten y1, we've gotten y2. Can we get the Roskian, the w? The Roskian will be equal to what? Cos. That's y1 sine 2x. Get the derivative of this one, which will be equal to what? Minus 2 sine 2x. Get the derivative of this one, that will be cos 2x. Let me explain that. When you differentiate ddx of cos 2x, okay, we are going to get the root function, which is what? The derivative of cosine is cos, okay, of the angle. Okay, then you now differentiate the composite function. The derivative of 2x is what? Is 2. That's what I did here. The same thing you do for sin 2x. You differentiate sine, you differentiate the sin, which will give you cos of the function, and then times the derivative of the composite function. Then get the determinant of that. This one times this one, that will give you cos squared 2x minus, but this one, there's a minus here, that's a plus. That will be cos squared 2x. Don't forget the 2 here, there's 2 here. Okay, this one times this one, that's this one times this one, that will give us 2 cos squared 2x. Okay, minus this one times this one, that's a minus 2 sine square 2x. Okay, so the Roskian is equal to what? 2 cos square 2x minus 2 sine square 2x. Okay, and minus minus, that's our plus. 2 is here, 2 is here. Take it out and open a bracket. So we have cos square 2x plus what? Sine square 2x. Okay, and whenever you have cos square 2 cos square some a function, cos square a function, sine square a function, what is important is that the function must be the same thing. Okay, once the function is the same thing, this will be equal to what? 1. The same thing also, this is 1, so times what? Times 2, so we have 2. So the Roskian is 2 times 1, which is 2. Don't forget also cos square 3x plus sine square 3x is also 1. What is important is that the angle, the function must be the same thing. The function must be the same thing. Your non-homogeneous part is a function of t. So anything you are getting must be a function of t. You have to be aware of the f of x. In this case now is f of t. The non-homogeneous part is f of t. So in this case, the auxiliary root will what? Will be this place, it will be t. This place it will be t. Where again, this one also t. T also. Everywhere you see x, just turn it to what? To t. Because it's a function of what? The functions of t. The functions of t. Everywhere you see your t, everywhere you see the x, put what? Put t there. Okay, so instead of saying f of x now, we're going to say f of t is equal to what? Is equal to sec square 4t. That's our that starts sec square 4t. Sec square 4t. Okay. So then y of p, yp will be v1 times y1 plus v2 times y2. Get your v1 and your v2 minus f of x y2 over a times the Roskian, okay, the t, because this one f of x is a function of t, so everything will be in form of t. Okay, and that will be equal to what? Minus my f of t is what? Sec square 2t. Y2 is what? Is sin 2t all over a is 1, Roskian is 2. Okay, so that's what we have in that place. That's what we have in that place. So what we need to do now is to just work with this one. What is the meaning of sec? Sec is 1 over cos square 2t. 1 over cos square 2t. And then times what? Times sine. That's what we have. Okay. Then we now have v1 is equal to, take the minus out. Okay. This, let u be equal to cos 2t. So the u, if you differentiate cosine, that will be minus sine 2t times the composite function. That's 2. So that's what we have there. So, and you can see it's the same with this. Okay. So that will be equal to minus integral of sin 2t dt. That's what we can allow this minus to come in. Let this minus outside there. Let it comes in. Okay. If it comes in, we're going to have this one times this one, and that will give us what? That will give us the only thing we need to do is to remove these 2 from here. Remove this 2 from here, and that will be du over 2 is equal to what? Is equal to minus sine 2t. Minus sine 2t. Minus sine 2t dt. Okay? So here, sine 2t dt, that's what? That's du over 2 all over. This cosine is u. That will be u what? U square. Okay? Then these two can come outside. That's minus 1 over 2. Okay? And then this one, raise it up. That will be u minus 2. V1, do the integral. The power plus 1. That will be u minus 1 over what? Over minus 1. Okay? And don't forget your half outside. Minus half. Minus 1 over 2 outside. Okay? When you want to integrate, if you have integral of u to the power minus 2, the u is going to be the power plus 1. That will be minus 2 plus 1. And whatever you have here over that. Okay? That's minus 1. So minus minus will cancel. So we have 1 over 2. Okay? 1 over 2. This minus here, that's 1 over u. That's 1 over u. Then we can return the u back, which will be equal to what? 1 over 2 times 1 over. My u is what? My u is cos 2. V2 is f of x, f of t, y1 over what? The Roskian. I don't have to waste time. 1 times 2, and then the t. And my f of t is sec square 2t. Y1, my y1 is what? Is my y1 is sin 2t. Is this sin 2t? Can I check that? My y1 is cos 2t. Cos 2t over what? Over t. Okay? And that will be equal to sec is 1 over cos square 2t times cos 2t dt. Okay? So we have the choice is ours. We have 1 here, we have multiple here. Okay? So this one we cancel, this one we cancel. It remains 1. That's 1 over cos 2t dt. And 1 over cosine, that's a sec 2t. Okay, that's sec 2t dt. Sec 2t dt. So that's what we have there. So the final conclusion for this one, when you integrate sec, it's going to give you natural logarithm of the function sec 2t plus tan 2t. Okay, and then you divide by the composite function